Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation with variable coefficients. So here we are going to solve a second order differential equation using reduction of order method. Let's get going. Problem. Solve y double dash plus 1 minus cot x into y dash minus y cot x equal to sine square x, given that y equal to e power minus x is a part of complementary function. So we are given a differential equation with variable coefficient, and also the given equation is in order 2, right? And also we are given a part of complementary function y equal to e power minus x, right? So we don't need to find complementary function again by using inspection method. Okay, solution. Given differential equation, y double dash plus 1 minus cot x into y dash minus y cot x equal to sine square x. Consider as equation number 1, which is in standard form. Y double dash plus py dash plus q into y equal to r, right? Or d square y by dx square plus p into dy by dx plus q into y equal to r. Now compare these two equations. We'll get p, q and r. We have p equal to 1 minus cot x, q equal to minus cot x, and r equal to sine square x. Here you are having y cot x, or you can just write it as minus cot x into y. Okay, so that it will be easy to compare q here, or quotient of y. Fine. Now we got p, q and r. Therefore, y equal to e power minus x is a part of CF of solution of 1, right, which is given. Now we need to find general solution, right? Let. So here, where u, which is u of x, equal to e power minus x. So we are having u equal to e power minus x. We need to find derivative of u with respect to x. So let's differentiate on both sides with respect to x. We'll get du by dx equal to derivative of e power minus x is minus e power x. When u equal to e power minus x, du by dx is minus e power minus x, right? Fine. Let y equal to uv be the general solution of 1. Then v is given by d square v by dx square plus p plus 2 by u into du by dx into dv by dx equal to r by u. Okay, consider this formula as equation number 2. Now, see, we are having u, right, which is e power minus x. So we'll find v now using this equation. Okay, first we will get capital V, and from this capital V we'll find small v, and later we'll substitute in the general solution formula y equal to uv. Now substitute p, u, du by dx, r and u in equation 2. Then d square v by dx square plus p is 1 minus cot x plus 2 by u e power minus x into du by dx is minus e power minus x into dv by dx equal to r by u. R is sine square x by u is e power minus x, right? Then this becomes d square v by dx square plus 1 minus cot x plus into minus, right? 2 by e power minus x into e power minus x into dv by dx equal to sine square x by e power minus x. Okay, so here e power minus x gets cancelled and we'll get d square v by dx square plus 1 minus cot x minus 2 into dv by dx equal to sine square x by e power minus x. This equation becomes d square v by dx square plus 1 minus 2 is minus 1 minus cot x into dv by dx equal to sine square x by e power minus x. Now let d small v by dx equal to capital V. Then d square small v by dx square will be d capital V by dx, right? Then the above equation becomes d capital V by dx plus minus 1 minus cot x into capital V equal to sine square x by e power minus x, which is linear equation in v and x, right? Or we can just take minus common from these two terms, then we'll get plus into minus 1 plus cot x into v here in the second term. We'll get dv by dx minus of 1 plus cot x into capital V equal to sine square x by e power minus x, considered as equation number 3, which is a linear equation in v and x. Now compare this linear equation with general form of linear equation v and x. Say d capital V by dx plus p1v equal to q1. Now by comparing these two, we'll get p1 and q1, right? Where p1 equal to minus 1 minus cot x and q1 equal to sine square x by e power minus x, right? So we'll find capital V using general solution of this linear equation. Okay, we know that integrating factor of the standard form of linear equation is given by e power integral p1 dx. So firstly we'll find integral p1 dx and then we'll go for if, and then we'll go for the general solution of this equation. I mean, we are going to use the general solution formula of the linear equation. V into if equal to integral q1 into if into integral differential dx plus integral constant c1. So firstly let's find integral p1 dx. Where p1 is minus 1 minus cot x into dx. We can write it as minus dx minus cot x dx, right? Minus integral dx minus integral cot x dx. We know that integral cot x dx is log sine x. If in case you forget the formula, just write cot x as cos x by sine x into dx. If f of x is sine x, then f dash of x is cos x, right? So this is of integral f dash of x by f of x into dx form, which is equals to log mod f of x or log f of x, right? From this we'll get log, here we are having f dash of x and in the denominator we are having f of x. So we can just compare this with integral f dash of x by f of x into dx, and we'll get integral cot x dx equals to log sin x for f of x equal to sin x. Okay, fine. And also we know that integral dx equal to x. Then integral p1 dx equal to integral minus integral dx is minus x minus integral cot x dx is log sin x. So we got integral p1 dx. Now let's find integrating factor, which is given by e power integral p1 dx, which is equals to e power minus x minus log sin x. Again we can split this as e power minus x into e power minus log sin x, right? Or we can write it as e power minus x into e power, we know that m log n can be written as log n power m, right? Then we can write minus log sin x as e power log sin x whole inverse, right? And also we know that e power log some function of x equal to function of x. So we can write e power log function of x as function of x. Then this becomes e power minus x into sin x whole inverse, right? Or e power minus x, or if equal to e power minus x into sin x whole inverse can be written as 1 by sin x. So integrating factor will be e power minus x by sin x. Okay. Therefore, integrating factor equal to e power minus x by sin x. Now let's use this formula to find capital V. V into integrating factor e power minus x by sin x equal to integral q1 sin square x by e power minus x into integrating factor e power minus x by sin x into dx plus c1. So here e power minus x gets cancelled and 1 sin x gets cancelled. Then we'll get integral sin x dx plus c1, right? We know that integral sin x dx is minus cos x plus integral constant c1. Now we are having v into e power minus x by sin x equal to minus cos x plus c1, right? Now take this term to RHS, we'll get v equal to minus cos x plus c1 into sin x by e power minus x. See, here we are having sin x by e power minus x, right? We can write e power minus x as 1 by e power x, then we'll get sin x into e power x or e power x into sin x. So we can write sin x into e power minus x as e power x sin x. Now the above equation becomes capital V equal to minus cos x plus c1 into e power x sin x, which is equals to minus e power x sin x into cos x plus c1 e power x sin x. Okay, since we know that capital V equals to d small v by or differential d small v by dx. Right? Now let's replace capital V with dv by dx. Okay. Now we are going to separate the variables. dv equal to minus e power x sin x. We'll just take this differential dx to RHS. So that we'll get minus e power x sin x cos x plus c1 e power x sin x into dx. Now this equation becomes dv equal to minus e power x sin x cos x dx plus c1 e power x sin x dx. Here the variables are separable, right? So we can perform integration. Integral dv equal to minus integral e power x sin x cos x dx plus c1 integral e power x sin x dx. Since we know that 2 sin x cos x equals to sin 2x, so we'll multiply and divide 2 to the integrand of the first term. Okay, then this becomes, I'll just write it here itself. Okay, 2 by 2, say. Then integral dv equal to minus, I'll take 1 by 2 outside the integral, and I'll write this 2 e power x sin x cos x dx as e power x into 2 sin x cos x into dx. Okay, and the second term remains the same. Then integral dv equal to minus 1 by 2 into e power x into sin 2x cos x can be replaced by sin 2x into dx plus c1 integral e power x sin x into dx. Since we know that integral e power x sin bx into dx equal to e power ax by a square plus b square into a sin bx minus b cos bx. So we'll apply this formula to these two integrals. This becomes integral dv is v equal to minus 1 by 2 into, now compare these two integrands, and for a equal to 1 and b equal to 2 we'll get e power ax 1 into x by a square 1 square plus b square 2 square into a sin bx 1 into sin bx 2x minus b cos bx plus c1 into, apply this formula for a equal to 1 and b equal to 1. Okay, compare these two integrands, then we'll get a equal to 1 and b equal to 1. So apply this formula now. E power 1 into x is e power x by 1 square plus 1 square into a 1 into sin bx, 1 into x is x minus b cos bx, 1 into x is x, right? Or we can write more clearly. One into x, 1 into x. Okay. Then b equal to minus 1 by 2 into e power x by 1 square is 1 plus 2 square is 4 into sin 2x minus 2 cos 2x plus c1 into e power x by 1 square is 1 plus 1 square 1 into sin x minus cos x. Then this becomes minus 1 by 2 into e power x by 1 plus 4, 5 into sine 2x plus 2 cos 2x plus c1 into e power x by 1 plus 1, 2 into sine x minus cos x. Right? This equals to minus e power x by 2 5s are 10 into sine 2x minus 2 cos 2x plus c1 into e power x by 2 into sine x minus cos x. See here, after applying integral formula, we'll get one integral constant, say c2. Okay, we'll get c2 integral constant. So this is our required v. We got v and we already have u. So let's write the general solution. Therefore, the general solution is given by y equal to u into v. Then y equal to u e power minus x into v minus e power x by 10 into sine 2x minus 2 cos 2x plus c1 into e power x by 2 into sine x minus cos x plus c2. Right? This becomes minus 1 by 10 into e power x into e power minus x into sine 2x minus 2 cos 2x plus c1 by 2 into e power x into e power minus x into sine x minus cos x plus e power minus x into c2 is c2 e power minus x. So we are having e power x into e power minus x in both the terms, right? This becomes, you can add the powers, we'll get x minus x, which is 0, and e power 0 is 1. Or we can write e power minus x as 1 by e power x, right? So here e power x gets cancelled and we'll get 1. So this becomes, since e power x into e power minus x is 1, so you'll get minus 1 by 10 into 1 into sine 2x minus 2 cos 2x plus c1 by 2 into 1 into sine x minus cos x plus c2 e power minus x. Then y equal to minus 1 by 10 into sine 2x minus 2 cos 2x plus c1 by 2 into sine x minus cos x plus c2 e power minus x is the required solution. So we have seen a problem from reduction of order in this video. Hope you'll understand. We'll see you in the next video. Till then, bye bye.